Hello everyone, this is Parvez Ahmmed from NC State University. I will be presenting on non-contact electrophysiology monitoring systems for assessment of canine-human interactions. Canine-assisted interactions have enormous potential in coping with the psychological disorders and mental stress. However, there are several challenges in the CAI research. The first one is the qualitative evaluation matrix, which relies on some biological markers. The second shortcoming is that only the human subject is monitored. And the most vital challenge is the experimental bias, which is caused when the therapy sessions are paused time to time for sample collection. To overcome these challenges, we have used quantitative assessment of psychophysiology of both the human and animal subject through the estimation of their heart rate and its variability. The best method to monitor heart rate is electrocardiography or ECG. However, it requires direct contact with the skin. Now we propose to use non-contact electrodes to overcome the barriers of experimental bias. We have some prior works of utilizing non-contact ECG systems in different human applications like physiological monitoring of the vehicle drivers, sleep monitoring of apnea patients. However, in the animal applications, non-contact systems has not been used. So we at NC State University collaborated with IMEC at Belgium to utilize their capacitively coupled ECG system in our use case. We performed in vivo experiments on a human and a canine subject to collect data using the non-contact ECG system and a reference ECG system to compare the results. Here you can see the data recorded from both the subjects. The top plots show the raw ECG signals, the second plot shows the filtered ECG signal along with the ECG signal from the reference device, and you can see the peaks overlapping on each other. Then we calculated the heart rate calculated from both the signals and the errors with respect to the reference devices, which is very small. If we compare the results obtained from the 5-minute long recordings, we see that the mean and standard deviation of the heart rate are almost equal from both the devices. We also tried to estimate the quality of the ECG signals by calculating the average correlation coefficients using the adaptive template matching method, and we see that the values are comparable to the reference device. In summary, we have explored a capacitively coupled ECG system for the assessment of psychophysiology of the human-animal dyads during interactive therapy sessions. This system utilizes non-contact electrodes, which would enable the sensor-embedded garments and bearings for more contactless assessment of the vital signs. This technology paves the way for quantitative assessment of the quality of canine-assisted interactions while ensuring intimate and disruption-free therapy sessions. Finally, I would like to finish by thanking the National Science Foundation for supporting our research through several grants, and thank you all for listening to my presentation.